Hello everyone, welcome back, and this video will be continuing our discussion on how to handle missing data. The last video of this video series or tutorial series on YouTube discussed the different methods of handling missing data through removing missing data. However, in this video we will be focusing more on more practical ways of handling missing data through imputing or filling missing data through either forward and backward filling, using statistical descriptions such as the mean, mode, and median, as well as filling missing values through interpolation. This YouTube series is based on the articles that I write on Medium, which you will find linked below in the description, and as part of a YouTube series in which we discover and showcase the different essential pandas functions and methods that I personally believe that everyone dealing with data through Python should have in their toolbox, and this is by no means an exhaustive list of tools, but should serve as a basis on which you can build upon from. So without further ado, let's get started. Another method for handling missing data is to fill it with statistical descriptions of that data. And to do so, we must ensure that our data distribution follows a normal distribution. If we don't, then we risk introducing bias to our dataset. And this method is the most common method out there. But what do we mean by replacing missing data through statistical descriptions? We mean replacing null values by the mean of a certain feature or column, the mode, or the median. And how do we know which statistical description to use? Well, you can use the mean if you have numerical data, use the median instead of mean if you have data that contains outliers, and use the mode in case you're handling categorical data. Let's use what we've learned and put it into practice. When in this section, we will be using the same data frame that we've created in our previous section, where we dropped the column with the most null values, which was building area. So we're going to continue with that data frame. So what I did here is I described all the data frame and also have this below it just to compare and infer which one or which ones are numeric in nature and which ones are categorical in nature. So we can infer that region name, council area, perhaps the seller, are all categorical data and the rest are numerical. And while working with statistical descriptions to fill in missing data and data frames, we must ensure that our data frame is a normal distribution. And for the simplicity of this tutorial, and since I don't want this tutorial to be longer than it is, I will not go into how we can figure out, test for normal distribution of our data, how to fix that. If it's not, I'll just assume it is in a normal distribution. So let's work with our categorical data first. We said if we had categorical data, we can use the mode to handle it. So we have categorical data here over here, in which it is the council area, the region name. Both of them are categorical in nature. So how can I deal with them? We can deal with them through filling them with the mode. And how can I calculate the mode of a column? So let's say mode of column 1. To calculate the mode, I will need to take the data frame, specify the column that I'm trying to calculate the mode for, which is region name, and then just apply the method dot mode. So when I print it, I get two values. I get the index and the value of the mode. But in order for us to mitigate that, we'll have to specify the the index 0. Okay? Now that I've got the mode, I've got to fill in all the missing values of this column, and to do that we need to introduce a new method called fillNA. So what it does is it takes all the missing values in a column and fills it with the value that you give it. In this case, I would like to fill all missing values with the mode of column 1, and I would like it to replace the null values. So I need to specify in place equals true. And when I run this, I previously have 3 values in the region name. When I run this, I should get 0. And that's exactly what happened. I've filled all the region name missing values with the mode of this column. And let's repeat that for the second categorical column. So mode of column 2. The second column that we have categorical data is the council area. And I'm going to figure out the mode and fill it in this column. And when I run the isNull.sum, I should get a 0 as well for the council area. So we've taken care of the categorical data. Now what if I wanted to take care, for example, the bedroom? I could use the mean. And to do that, it's very simple. I just do the exact same. I take the same code and I just modify the name and I just specify that the function or the method that I'll be using is the mean. And then, of course, I'm going to fill the mean of column 1 in the column that I'd like to fill it in. And I'll say that I want to fill it in the bedroom 2 column. So I'm filling in the missing values of bedroom 2 with the mean of all the values within the column of bedroom 2. And in this case, I would not need to specify. So when I run column 1, I don't need, what I get is, I get exact numbers. I don't get a series like I did in the mode, so I do not need to specify this index. So when I run this again, bedroom 2 had about 8,200. It should now have 0 values of missing values. And let's take care of the distance and postcode as well. So I'll do the exact same thing for postcode. And distance, which only had 1 missing value. And then when I run the isNull.sum, I should get 0 null values. And I have other missing values as well that I will be dealing with in the next sections. Now, what if I wanted to fill it in with the median? It's the same exact thing. I would just need to change the method to median. And it should work out. But I will not be filling it in. I just want to print the median of column 2. Let's see what we get. We get a value which is the middle of the whole column. So that's how we can find the median. And of course, we can follow the same procedure we did for the mode and the mean. If we wanted to fill in our column fill in our missing values in our column with the median. Another way we can fill our data or fill our missing data is through either backward filling or forward filling. Forward filling is the procedure of filling our missing values with the last value before it that wasn't a null value. So essentially what it does is if we have a null value, it goes backwards in the column to the data points prior and takes the most recent data point that wasn't a null value and keeps it where the null value is right now. While backward filling is the exact opposite, because what happens is it takes the value after it, the data point after it, the most recent or closest data point that's after it, that is not a null value, and essentially fills that missing value with it. And to use them, it's very easy. So let's take a look at how we can use them to fill our missing data in our data frame. So let's put that to practice. In our old data frame, no feature underscore data frame, we have a lot of things left for us to mitigate in terms of missing values. Let's say we'd like to take the land size, let's say land size, and use forward fill to fill in the missing values. How can we do that? What we can do is take the no feature df and specify that we're trying to forward fill the land size using ffill, and we're going to specify that we would like to fill it in place of the null values. So when we run that, and later on print the null sum, we must get, okay, there's a small error over here. We must get the following, where we should have 0 null values, and in fact we do not have any null values for land size after forward filling it, after performing forward fill. And similarly, let's do the same for our backwards fill. And rather than specifying that it's forward fill, let's specify that it's backward fill and observe what happens. Let's choose another column. Let's say I'm going to choose the bathroom and backward fill. And that's exactly what happens. We backward fill about 8,200 until we get no null values left. Another way we can write this is through using the fill NA that we've learned earlier when working with the statistical descriptions. So how can we use the fill NA to fill in through forward filling and backward filling? So let's say we would like to work with the longitude and the latitude, and we want to forward fill and backward fill these two columns. So what we can do is, using the same thing, rather than saying ffill, fill in A, and specifying the method to be ffill, and rather than forward filling the land size column, we would like to forward fill the longitude. And of course, we shouldn't forget in place equals true, because it makes all the difference. This ensures that we are replacing the null values with forward filling. And then when I run this again, I get that for the longitude, I forward filled every single null value. And it's basically the same thing, just different ways of writing it. Similarly, if I'd like to do the same thing for backward filling, then I would need to specify the column, which in this case will be the latitude. Then apply fill NA method, specify the method for filling the null values, which will be backward fill, and we must make sure that we are replacing the null values with backward filling. Another way of writing this is, rather than writing this in place equals true, equating what we're doing here to the column we're working at. So when we run this, and I run the isNull.sum, I get zero null values over here. So this is just basically another way of displaying or writing or coding backwards and forwards fill. In the next section, we will be looking at how we can use both backwards and forwards filling for some use cases where they may present as a viable solution, and we will look at how we can fill missing values at a specific column with an arbitrary value. Now, sometimes what happens is we might have a data set, like the one that we have right here, with null values at either the first row or the last row. So let's check. Over here we do have for the price and for the year built null values at the beginning of the data frame, and for the tail it seems like that we don't have any null values. So what happens is when we have null values at the end, at the last row of the data frame, and we perform backwards fill, since backwards fill essentially takes the value, the next data point, and there is no next data point, it cannot backward fill the last row of the data frame. And similarly, for forwards fill, when I'm trying to apply forward fill to this column, what happens is for the first column, since we have a null value, there isn't a data point before it. It's the first one. It's the first row. So the forward fill cannot be applied correctly on the year built because there's nothing for it to look before this entry to fill it in. So there's nothing to bring forward to fill this null value, and similarly this null value. So if I perform for year built for the year built forwards fill, and then I display the is null.sum, I'll notice that I will not be able, of course, we should always specify in place equals true and make sure that we're specifying the correct data frame. So when I display the isNull.sum, I'll notice that yes, I've made things a lot better. I've cleared about 20,000 null values using forward fill. However, I did not take care of the first two in the data frame. And for us to mitigate or to, let's say, make sure we don't run into this, we can use both backwards and forwards fill for these types of scenarios. So what we essentially do is we specify we're defining the column that we're trying to make changes to, and we're applying both the forward fill and backwards fill together. And when I run this and then check if we have any null values for this specific column, we can see that we got rid of all the null values because we've applied both forward fill and back. Another way we can also fill in missing data is through filling this missing data with an arbitrary value. such as the number 0. So we see that for property count, we have about 3 missing values. So what we can do is specify that for the column property count, we would like to apply fill in A, filling missing values, and fill in the missing values with the number 0. And then when I run this again, we can see that we took care. Yes, do not forget in place equals true, as it makes all the difference. So when I run this and run the isNull.sum again, I should get a 0 count for the property count missing values. Now finally, the last and most recommended method is the interpolation. The last method for handling data points and the most recommended is interpolation. Interpolation is a mathematical method that is used to estimate values between known data points. It does so through constructing a function or a curve that passes through the given data points in order to approximate the values at intermediate positions. Instead of relying on existing data points to fill missing values in data, such as the mean or through backwards or forwards filling, interpolation gives us a way to make educated guesses about the values in those intermediate positions where we have null values. And there are different methods for interpolation that you could use, such as linear, nearest, zero, S-linear, quadratic, cubic, barycentric, polynomial, where you can specify the method of interpolation through the code that we will be observing in this section of this tutorial. So we have 2 more values left, or 2 more columns left with missing values. And for us to understand interpolation, we'll be applying it to those 2 columns. Starting with the car column, as we've always done, we will always specify the column and then apply the method interpolate rather than fill in A, and then make sure that we specify that we're going to fill it in place of the null values. Now, by default, the interpolation uses the linear type of interpolation. So when I go ahead and run this, the missing values of the column car will be filled with linear interpolation of that column. So when I run this, I should get a 0 for the column car, meaning that I've taken care of all the missing values for this specific column. Now finally, for price, I will be using a more complex interpolation. So rather than using linear interpolation, which is the default, I will use the polynomial, and I will specify that yes, I do want it in place of the null values, and the method is polynomial, and I would like the polynomial to be in the second order. And then when I run the isNull.sum, I would have noticed that I have addressed the issue with price except for one value. If we remember, when we visualize the head of this dataset, we can see that we have one missing value for price, and it's at the first row. So how can I mitigate this issue? We can simply, from what we've learned so far, since when we preview the head of the data frame, we can see that in the first row we will have a null value in the first column, in the first row of the price column. So therefore, we can easily mitigate this issue through what we've learned so far by backwards filling. And when we comment this code and visualize the null count through isNull.sum, we can see that we've dealt with all the missing values. And this marks the end of this video, where we've looked at the different methods to handle missing data, like filling the missing data through forward and backward filling in statistical descriptions, and even through interpolation. In the next videos of this series, we will look at 3 more important or essential functions, in my opinion. One that concerns the calculation of the frequency of the redundancy of values within a column through using value counts and the unique values within a column, and how to finally, after finishing up our data manipulation, export this new data that we have as an Excel or CSV file. So stay tuned for that video, and thank you for watching.